We know that a real number k is the zero of a polynomial p of x if p of k equals to 0. Now we have already started this in the previous section. Now we will understand in this section what is the geometrical meaning of the 0 of this polynomial. That means we will understand it by graphs. Now let's see the geometrical representation of the linear, quadratic and cubic polynomials and the geometric meaning of their zeros. Okay, now let us start with the linear polynomial. Okay. Now, a linear polynomial can be expressed as ax plus b, where a is not equal to 0, right? And what is a linear polynomial? It is a polynomial with degree 1, right? So, now we know that this is a linear polynomial. Now, let y equals to ax plus b. Now we have already studied that y equals to ax plus b in ninth class, that it is when we represent it on a graph, we get a straight line. Okay, now let us understand with an example. Let y equals to 2x plus 3. This is an example. Now let us put on the values. If x equals to minus 2, we get minus 1 as y equals to 2x plus 3. We put the value of 2 over minus 2 over here, we get minus 1. Okay, now if we put the value of x equals to 2, we get 7. If you put 0, we get 3. If you put minus 3 by 2, you get 0. Okay, now let us plot these points on a graph. Okay, now we have a graph chart here. Alright, now let us plot the x-axis. This is the y-axis, and let us plot the x-axis. Alright, so now we have, if x equals to minus 2 over here, then y equals to minus 1. So this is the point. Okay, if x equals to 2 over here, then y equals to 7 over here. If x equal to 0, then y equals to 3. So over here, if x equals to minus 3 by 2 over here, then y equals to 0. Okay, now when we connect all these points, what do we get? We get a straight line which is called y equals to 2x plus 3. So this graph intersects the x-axis. Where does it intersect? What is this point? This point is minus 3 by 2 comma 0. Now 0 of the polynomial, if you note, this is, what is the 0 of this polynomial? It is px is equal to 0. This implies 2x plus 3 equal to 0. This implies x equals to minus 3 by 2. Now this is the same point where this graph intersects the x-axis. So the 0 of the polynomial 2x plus 3 is the x-coordinate of the point where the graph of y equals to 2x plus 3 intersects the x-axis, right? So this and this point are same. So what can we say? For a linear polynomial ax plus b, where a is not equal to 0, the graph of y, y equals to ax plus b is a straight line, and it intersects the x-axis at only one point. What is that point? Minus b by a comma 0. So what can we say? The linear polynomial ax plus b has only one 0. What is it? What is that 0? Which is the x coordinate of the point where the graph of y equals to ax plus b intersects the x-axis. Now we have seen that the 0 of this polynomial p of x equals to 2x plus 3. This is the same value as the x coordinate of y equals to 2x plus 3. So here we have only one 0. Now let us come to the quadratic polynomials. Now we know a quadratic polynomial is a polynomial whose degree is 2. Now it can be represented as ax square plus bx plus c, where a is not equal to 0. Okay. Now let us consider one polynomial. Let's say a polynomial is x square minus 3x minus 4. Now let y equals to x square minus 3x minus 4. So now let us try to plot these points. Okay, now we know that y equals to x square minus 3x minus 4. If we substitute the values, some random values, let's say if x equals to minus 2, y equals to 6. If x is minus 1, this is 0. If x is 0, this is 4. 1 minus 6, 2 minus 6, 3 minus 4, 4, 0, 5 and 6. We have obtained these values. Okay. Now from here, if you see what is the 0 of this polynomial, the 0 of the polynomial is when if this is p of x, the 0 is when p of x equal to 0. So that means when this value equals to 0, that means when y equal to 0, at those point we get the 0 of this polynomial. So where is y equal to 0? Over here and over here. So from this table we can say minus 1 comma 4 are the zeros of the polynomial px. Okay, now let us try to represent this graphically. But you have to understand one thing, that all this thing from for quadratic polynomials and for cubic polynomials, whatever I'm trying to show here, this won't come in your exam, but this is important for you to understand. So this is only for understanding point of view. Okay, now let us try to plot these points. Okay, so let us draw this as the y-axis and this is our x-axis. Okay, this is y-axis and this is x-axis. Okay, now we have, when we have x equals to minus 2, x equals to minus 2 over here, we have y equals to 6. Okay, now when we have x equals to minus 1, we have y equal to 0. Now when we have x equal to 0, we have y equals to minus 4. So here this point is. Okay, so when we have x equal to 1, we have y equals to minus 6. Where we have x equals to 2, we have y equals to minus 6. Alright. When we have x equals to 3, we have y equals to minus 4. Okay, over here. Now when we have 4, then y equals to 0. When we have 5, then y equals to 6, then over here. So if we connect all these points, so this is not accurate, but for your understanding, this shape and this shape, whenever we get, we this is called a parabola. Okay, so when you plot a quadratic equation like something like this, y equals to x square minus 3x minus 4, you get a parabola. Here the parabola is open upwards and in some cases it might be downwards. So we will understand those also, but for now let us understand this parabola. This is an upward shaped parabola and the graph of this, now this graph is called the graph of x square minus 3x minus 4, and this intersects the x-axis at which points? At minus 1 comma 0 and 4 comma 0. Now you note that the 0 of the polynomial x square minus 3x minus 4 were minus 1 and 4, and the graph of the equation y equals to x square minus 3x minus 4 intersects x-axis at at this point -1 and -1 and -4. So the 0, we can say the 0 of the quadratic polynomial x square minus 3x minus 4 are what? Are the x coordinates of the points where the graph of y equals to x square minus 3x minus 4 intersects the x-axis. Let's generalize that for any quadratic equation, polynomial ax square plus bx plus c, where a is not equal to 0, the graph of the corresponding equation y equals to ax square plus bx plus c, what is it? Is a, like I have said before, it is a parabola. Okay, and parabola can be of two types. It can be of this shape or of this shape. That means it can be either open upwards or it can be open downwards. So if you are given an equation or a polynomial, you can like without plotting your graph, you can figure out if it is facing upwards or it is facing downwards. How? For example, if you have this polynomial and if you plot the graph of the corresponding equation, if a is greater than 0, right, then it is open upwards, and if a is less than 0, then it is open downwards. Like for example, 2x square plus 3x minus 4, and over here 2 minus 2x square plus 3x minus 4, right? So this will be facing, the parabola would be open upwards, here the parabola would be facing downwards. And of course the zeros of the quadratic polynomial ax square plus bx plus c, where a is not equal to 0, are the coordinates of the points where the parabola of y equals to ax square plus bx plus c intersects the x-axis, right? Here also in this previous example, we saw that the 0 of this polynomial x square minus 3x minus 4 is the same as the x coordinates of the corresponding graph of the equation that we plotted, right? And it is a parabola. Now let us understand something about the quadratic equations, right? About the roots of the quadratic equation. Okay, now we know that the root of the quadratic equation are, if the equation is suppose y equals to ax square plus bx plus c, then the roots are minus b plus minus b square minus 4ac upon 2a. Okay, and here we get three cases. First case is we get two distinct roots if this value root b square minus 4ac is greater than 0. Okay, we get two identical roots if b square minus root b square minus 4ac equal to 0, and we get no real roots if b square minus 4ac is less than 0. So now for quadratic polynomials also, we have three cases. The case one is we get two distinct zeros of the polynomial ax square plus bx plus c. So this means that the graph of the equation y equals to ax square plus bx plus c cuts the x-axis at two distinct points, right? For example, the graphs would be something like this. So it would be cutting the x-axis at two distinct points, either facing downwards or facing upwards, and it would be cutting at two different points. Now let's come to case number 2, where we have only one zero of the polynomial ax square plus bx plus c. That means the graph of y equals to ax square plus bx plus c cuts the x-axis at only one point, right? For example, if it is facing upwards, then it would be something like this, and it would be cutting the x-axis at such a one point. Sorry, if it is facing downwards, then it would be something like this, cutting x-axis only at one point. So this point A is the zero of the polynomial ax square plus bx plus c. Now let's come to case number 3, where there is no zero of the polynomial ax square plus bx plus c. Okay, so this means the graph of y equals to ax square plus bx plus c is either completely above the x axis or completely below the x axis. How? Like this, either completely above or completely below. Okay, and of course always in the case of quadratic polynomials, the graph would be a parabola. Okay, so from all the three cases we can say that a quadratic polynomial can have either two distinct zeros or one zero or no zero. So a polynomial of degree 2, a quadratic polynomial has at most two zeros, or we can say a polynomial of degree 2 has at most, मतलब ज़्यादा से ज़्यादा two zeros, not more than two zeros. As we have seen in case 1 there are two zeros, in case 2 there is one zero, and in this case there is no zero. Now let's come to the cubic polynomials. Okay, now this also you have to only understand, it won't come in your exam. All right, so now let us start with an example to understand better. Now let us consider one cubic polynomial, say x cube minus 4x. Okay, so now let y equals to, let us make a corresponding equation for this. Y equals to x cube minus 4x. Okay, now let's find the values. If x equals to, if x equals to minus 2, then y equal to 0. If x equal to minus 1, this is 3. If x equal to 0, this is 0. If x equal to 1, this is minus 3. If x equal to 2, then we have 0. Now from here, if we see, uh, for the polynomial, what is the, for the polynomial p of x equals to x cube minus 4x, what is the 0? If p of x equal to 0, so x cube minus 4x equal to 0, that means y is 0. So y 0, when do we get y equals to 0? From this table, over here, over here, and over here. So in these cases the value of x is the 0 of the cubic polynomial. So minus 2, 0 and 2 are the zeros of the polynomial x cube minus 4x. Now let us plot the graph from this table. Now let us plot some values. Let us make this as y-axis, and let us consider this as our x-axis. Now when x equals to minus 2, y equals to 0. So this is one point. When x equals to minus 1, y equals to 3. This is another point. When x equal to 0, y equal to 0. When x equal to 1, y equals to minus 3. So this point, when x equals to 2, y equals to 0. Alright, now so when we plot these points, connect these points, we get a graph like this. Alright, so this graph is y equals to x cube minus 4x. Okay, so the graph of x cube minus 4x, y equals to x cube minus 4x intersects the x-axis at minus 2 comma 0, 0 comma 0 and 2 comma 0. Now notice that what are the x coordinates of the points where the graph of this equation intersects the x-axis. It is at minus 2, 0 and 2. And these are the same points as the zeros of the polynomial. So what I can say, the zeros of the cubic polynomial x cube minus 4x are the x coordinates of the points where the graph of y equals to x cube minus 4x intersects the x-axis. Now let us consider a few more examples. Let us consider one cubic polynomial as x cube. So let y equals to x cube. So from here we can say 0 is the only 0 of this polynomial. Okay, now let us plot this graph. Let this is py axis. Let this be x-axis. Now the graph of y equals to x cube looks something like this. So 0 is the only x coordinate where the graph of y equals to x cube intersects the x-axis, and 0 is the only 0. Okay, now let us consider one more example. Let us consider a cubic polynomial x cube minus x square. So let y equals to x cube minus x square. So for your understanding, we can write it as x into x minus 1. So from here I can say x equal to 0 and x equal to 1 are the zeros of this polynomial. Okay, now let us plot this. You don't have to plot these points in your exam. This is only for understanding purposes. Okay, now I'll plot them quickly for you. So the graph of y equals to x cube minus x square looks something like this. Okay, from here I can say that the graph of y equals to x cube minus x square intersects the x-axis at what points? 0 comma 0 and 1 comma 0, and the x coordinates of the points where the graph of y equals to x cube minus x square intersects are what are the x coordinates? Are 0 and 1, and 0 and 1 are the same as the zeros of this polynomial. So for a cubic polynomial, we have seen there can be only one zero. Here we have seen there are two, and in the example in the beginning we had seen that there can be three zeros also. So for a cubic polynomial or a polynomial of degree 3, there are at most three zeros. So we can generalize this as, given a polynomial p of x of degree n, the graph of y equals to px intersects the x-axis at most n points. Therefore, a polynomial px of degree n has at most n roots. Alright, so if you like the video, please subscribe to the channel and share it with your friends. If you have any queries, share them down in the comment section below.